Hi, third graders. I'm going to teach you lesson 25 from our Module 5 math unit, okay? And this is the application problem. I'm going to bring this a little bit closer. This might be more helpful. Here's the application problem. It says Lincoln drinks 1/8 gallon of milk every morning. How many days will it take Lincoln to drink 1 gallon of milk? Well, if he drinks 1/8 every day, that means he would say take the whole gallon and partition or split it into 8 equal parts. So if he's drinking 1/8 every day, how many days would it take him to drink the whole thing? Well, how many eighths would be in the one whole? 8/8, right? Because whenever the top number and the bottom number of the fraction are the same number, that is equal to 1 whole. So picture a whole gallon of milk partitioned into 8 different parts or poured equally into 8 different cups, right? He would be drinking 1/8 a day. So on my number line starts at 0, and here is the whole number 1. So you're going to imagine that this is 1 whole gallon, right? So if we start here with 0/8, because there are 1, 2, 3, 4, 5, 6, 7, 8 equal parts in the 1 whole gallon. Each tick mark on my number line is 1/8. 1/8, this is 2/8, right? So if he starts, he drinks nothing. And then on the first day, he drinks 1/8. On the second day, he drinks another 1/8. So now he has had 2/8 and 3/8 and 4/8 and 5/8 and 6/8 and 7/8 and 8/8. And finally, 8/8, he has had the whole gallon. So it would take him 8 days. So how many days will it take Lincoln to drink 1 gallon of milk? You showed it on your number line. That's what it says to do in the application problem. And you would write, it will take, I'm just going to write L, 8 days to drink 1 gallon of milk if he drinks 1/8 of a gallon a day. Okay? The second part to that problem says, how many days will it take Lincoln to drink 2 gallons? Well, if it took him 8 days to drink 1 gallon and he's still drinking just 1/8 a day, it's obviously going to double, right? So I would extend my number line to 2 whole gallons. This was 1 gallon. Here's 2 whole gallons. And I would keep counting by 8s. If 1 was equal to 8/8, then the next 8th is 9/8 and 10/8. And I would just keep counting by 8s. If this is 10/8, 11/8, 12/8, 13/8, 14/8, 15/8, and at 2 wholes, I'm at 16/8. And I made that bigger because I want you to be able to see something. Remember this trick I showed you. If the whole number is 2, I can multiply 2, the whole number, by the denominator or the bottom number of the fraction, right? So 2 times 8 is 16. That gives me the numerator, the top number of the fraction. That works with the whole numbers. So how many days will it take Lincoln to drink 2 gallons? I would write a whole sentence, okay, but I'm trying to move quickly. So I would say 16 days. That's how long it took him to drink 2 gallons. 16 days to drink 2 whole gallons if he drinks 1/8 a day. 1/8 gallon of milk a day. Okay, and that's how you would show it on your number line. Okay, I want to move on to the lesson. I'm going to take this down. Okay. All right, and I have my next visual to come up here, right? This is the lesson. It will help you understand this this lesson a little bit better. Okay, so I want to show you something about what happens when we're expressing, whole numbers as fractions. I'm just going to pick up my marker. And I'm back. Okay, so I'm going to express whole numbers as fractions. And we've done this before. This really isn't new. Okay? But whole numbers have a value of fractions. And what I told you last week is that someday when you're older math kids, okay, and you'll be doing math for a lifetime, right? You'll be doing math all of your life. You will have to understand that that every number has a value, and every fraction has a value as a whole, every whole number has a value of a fraction, okay? So we think of fractions as being parts of something, of being part of a whole, but sometimes a whole, you'll have to express it as a fraction. So this is like the setup or the base for what you'll be doing someday down the road. And you might think, oh, I won't be doing that for a long time. But hopefully when you're in 8th grade or in 11th grade, you'll say, oh, I remember when I was in 3rd grade and Mrs. Morgan showed me that, right? Okay, so if this is my whole rectangle and I partition it into 3 equal parts. If I partition it into 3 equal parts, I have thirds, right? 1/3, 2/3, 3/3. Each part is a third. And if I'm talking about the whole thing, then I'm talking about the one whole thing, and that fraction is 3/3. 3/3 is equal to 1. Let me hold that to you a little closer. 3/3 is equal to 1 because I am partitioning one whole thing into 3 equal parts. And I'm using the whole, all 3/3, right? So all 3/3 is equal to 1. The same thing happens, and I can do it any way I want, if I partition this rectangle, notice they're about the same size, into 2 equal parts. When I partition into 2 equal parts, I have halves, right? The fractional unit would be halves. If I'm talking about both of those half and half, I have 2 halves, right? 2 halves, and it looks like this. 2/2 is equal to 1 whole. So what if I'm talking about this whole thing? What's the fraction for that? That's tricky. We don't use that too often, but like I said, someday you will, and you'll have to know how to put a whole number and express it as a fraction, okay? So if I were to say, what is 1? This is 1. It's a whole thing. I'm not partitioning it into equal parts. I'm leaving it as a whole. It still has a value as a fraction, and you would express it this way, 1/1, okay? And if you look, there's a pattern, 3/3, 2/2, 1/1. But what do they have in common? They're all equivalent to the whole number 1. This one is 3/3 because it's partitioned into 3 equal parts. This one is 2/2, or 2 halves, because it's partitioned into 2 equal parts. And this one is not partitioned into any equal parts. So if I were going to use it as a fraction, if I needed to use it as a fraction, just like this, 1/1, okay? On the number line, for this one, notice my number line, I hope you can see it. My number line starts at 0 and it goes to 1. And this is thirds, right? It looks like this, 3 equal parts. 0/3, 1/3, 2/3, not really equal, and 3/3 is equivalent to the whole number 1. This one would be halves. 0 halves, 1 half, and 2 halves is equivalent to the whole number 1. What do I do with this number line if I want to have it represent this model here? Do I partition it into any equal parts? No, because it's one whole, okay? And if I were going to make the fraction or show you the fraction, it would be 1 over 1 is equal to the whole number 1. Okay? All right, I hope that is helpful. I am going to take a look at the problem set and see what we have. I'm limited with my space, so I'm just going to move over here and show you. Okay, so what they're showing you on the problem set is they're showing you multiple models, rectangles, and the first one is done for you. Okay, so they show you this. They show you one hole, and they tell you that this is equal to one hole. And on theirs, the whole thing is shaded in, and it's equal to one hole. Okay, the second model is the same shape, it's the same size. Remember, that's how we can compare, okay? And it's partitioned into 3 equal parts, just like the one I showed you, okay? And all 3 are shaded in. Okay, and it's one whole thing, so the fraction is 3/3. The next one, they show you like this. Two equal parts. But wait, there's more. And they're telling you that this is like a set. Okay? And they want you to think of this as one model. But how many holes do we have? We have 2 holes, right? Both are partitioned into 2 equal parts or halves. So suppose it looks like this. Oh goodness, do you hear my dog barking? Because my girls are being silly. And they're making the dog bark, even though they know their mother is teaching a lesson. What fraction is shaded? How many halves are shaded here? 1 half, 2 half, 3 halves. 3 halves are shaded. Okay? So let's see, this is a different one. Suppose our whole things look like this. And if this is one whole model, okay, and all 3 of them are shaded, what fraction is shaded? Well, here's what I know. There's 3 holes, right? So I could say 3 holes are shaded. So what is that fraction? Well, think about what happened before when we had 1. Okay, if it's 3 whole things and they're all shaded, my fraction for the whole number 3 is 3 over 1. A number over over 1, if 1 is the denominator, this is the whole number. It's equal to 3, right? Remember this trick. The denominator times the whole number. What's 3 times 1? It's 3. It gives me the numerator. Okay? That is basically it. The front of the problem set is very simple. The back of it is, just look at it, okay? It's a number line, and they're just whole numbers. So now you know, whole numbers on a number line, I'm struggling with all of my markers today. The whole numbers on a number line, okay, if I start with 0, these are whole numbers. What's the fraction for each of them? Well, what did we just say here? When you put a number, when you use a whole and turn it into a fraction, you just put the whole number over 1, okay? So this really doesn't make much sense. The fraction for 0 is 0 over 1. The fraction for one whole thing is 1 over 1. The fraction for 2 whole things is 2 over 1. We already know the fraction for 3 whole things is 3 over 1. The fraction for 4 whole things is 4 over 1, and so on, okay? That's your lesson today, boys and girls. That's what the problem set is basically all about, okay? It's expressing a whole number as a fraction. And like I said, it doesn't seem like it's important right now, but someday it will be. So this is just good information to keep stored up here in your brain, okay? I hope that was helpful. There's also the YouTube video for lesson 25 that you can watch on YouTube. It's always on the weekly schedule. Okay, bye boys and girls.